Okay, number one is find the domain of the function. It's an even root. It's a fourth root. That means the radicand. The radicand is this over here. Give me 1 second. I'm going to highlight that for you. That's the radicand. The radicand must be greater than or equal to 0. What do you do here? You factor it. This x comes out. You get 1 minus x. On the number line, you list the zeros. There are 2 zeros. One is at 0, and the other one is at 1. You're going to test points out on the intervals. A good point after 1 would be 2. If you plug that in, you would get positive times a negative. Well, positive times a negative is a negative, so this interval over here is all negative. That's certainly not greater than 0, so I would not shade that in. Between 0 and 1, I choose a half. What do you get there? Positive for the first factor. Second factor is positive. Well, positive times a positive is a positive, and positive numbers are clearly greater than 0. So that gets shaded in. Next up, below 0, minus 1 would be a good choice. Plug it in. Negative number. Next number is going to be positive. Well, a negative times a positive negative, and certainly negative numbers are not greater than 0. The other thing we have to wonder about is it ever equal to 0, and it is at 0 and at 1. So what's the domain going to be? Let's write this down. The domain is going to be x on the interval between 0 and 1. Put a box on it and go to the next question. Analyze for symmetry. There's 3 types of symmetries that we're looking for. There's an even symmetry. There's an odd symmetry and an exact symmetry. Let's just do one at a time. An even symmetry, what do? You replace x by minus x. Let's do that. And what do you get there? 2y equals minus x cubed. This is clearly not the same thing. So when I say same thing, it's not the same thing as this. So it's not even. All right, let's move on to odd. How do you do odd? You replace x by minus x, and y by minus y. Let's do that. Simplify. I would multiply both sides by minus 1. You get 2y is equal to x cubed. This is clearly the same thing. It is odd. Let's do, excuse me, x-axis symmetry. How do you do that? You replace y by minus y. And that would give you minus 2y equals x cubed. And that's clearly not the same thing. All right, it's only odd symmetry. But let's do number 3. And that's a rational inequality. X plus 12, x plus 2, minus 3. Yes, we have to get it compared to 0. Common denominator be x plus 2, x plus 2. Common denominator is x plus 2. What's the numerator going to be? Well, let's take a look at it. It's going to be x minus 3x, which is minus 2x. And then you can get 12 minus 6, which is 6. On a number line, I'm going to list the zeros of the top and of the bottom. The bottom becomes 0 at minus 2, and the top becomes 0 at 3. I'm going to take a test point on those intervals. For example, after 3, I would choose 4. When you plug it in, you get negative on top. When you plug it in bottom, you get positive. Overall, it's negative. What does that mean? It's less than 0. Well, I certainly want the things that are less than 0. All right? Let's go between minus 2 and 3. I probably would choose 0. What do you get on top? Positive number. And on bottom, you get a positive number. Well, positive divided by positive is a positive. So that would not be shaded in because it's not less than 0. Next up, below minus 2, like minus 3, what do you get? Positive on top. On bottom, you'd get a negative number. What do you get there? Negative overall. And negative numbers are clearly less than 0. So that gets shaded in. The only question I can ask is when is equal to 0? At 3, it becomes 0. But at minus 2, it's not equal to 0 because there's a division by 0. So what do you get over here? The interval is going to be from minus infinity up to minus 2. It's not touching minus 2. And then it starts up again at 3, but it touches it, and it goes off to infinity. All right, let me remind you what you're doing over here. You're solving it. We did solve it, and we want to express the answer in 2 ways: as a graph on a number line, which we just did, and interval notation, and we did both. By the way, you don't have to box the graph, but this is the graph, by the way. All right. Now, again, make sure you're answering each question as they asked you. Like domain, I boxed it. the symmetry I boxed it, and there's work down, and this is going to be a graph and the intervals. All right, let's move on. The next question is a quadratic inequality, and you factor it. And part of factoring those things is just making sure you can factor it correctly. And it's probably going to be a pretty simple factorization problem. And I'm going to say 4 and 1 minus plus. That's 3x squared. You get minus 12x plus 1x is minus 11x. Yeah, seems to work out okay. Number line goes down. What goes on a number line? Two numbers, the zeros. The zeros of the second factor, the zero of the second factor is 4. And the zero of the first factor would be minus 1/3. What are you going to do now? Test. After 4, I would choose 5. Plug it in. You get positive times a positive, which is positive. Positive numbers are greater than 0, so I would shade that in. I would take a number between minus 1/3 and 4. I would say 0. Plug it in. You get positive times a negative. Well, that means it's negative overall. I would not shade that in because it's not greater than 0. I'd go below minus 1/3, pick minus 1, plug it in. What do you get? A negative number times a negative number, which is a positive number. Positive numbers are greater than 0, so I would shade that in. The only other question you're asking is it equal to 0? Certainly at 4, if you plug it in, you get 0, and at minus 1/3. Let's write the answer down. It's going to be minus infinity up to minus 1/3. It is touching it, union. It starts at 4 and goes off to infinity. It does touch to 4, by the way. So there's two ways. I'm going to put this down. A graph and a number line. I did that. An interval. I did that as well. If you want to box the graph, you can. And we're done. Move on to the next question. Next question, again, it says what's the x-intercept. Let's write it down. It's a multiple choice question. I hope you're not guessing at these things, but if you are, it's okay to guess if you don't know what you're doing. But you set y to be 0. And what do you get over here? Well, you get the root of 3x cubed over 3 minus 3. I probably would multiply both sides by 3 now. You get 0 equals the square root of 3x cubed minus 9. I would add 9 to both sides. You get this over here. I probably would square both sides now. You're going to get 81 equals 3x cubed. I would divide both sides by 3. You get x cubed is 27. And now x is obviously the number 3. So this would be, correct answer would be B. All right, let's keep moving along. This is the same question we did at the board, before the exam. And I'm going to say, for the most part, every question we give you is pretty much you've seen before or something almost identical to it. But this is an identical problem. And the way I'm going to do it, I'll write it down for you. I would probably, let me write it down for you first. I probably would subtract 5 from both sides, and I would add this to both sides. Again, you could add and subtract anything you want from both sides of an inequality without any effect on it. What do you get there? 3. On the other side, you're going to get the absolute value of x over 3 plus 6. Now, this is the form we like. And the form is going to be, it basically says this thing here has to be greater than 3 units from the origin. I understand what that means, by the way. That means that x plus 3 plus 6 must be less than minus 3, or the x over 3 plus 6 has to be greater than 3. All right? What do you do now? Subtract, 6 from both sides. You get x over 3. That would be, again, if I subtract 6, I get minus 9. Or, doing the same thing over here, by the way, x over 3. And if you subtract 6 from those, you get minus 3. Then I would multiply both sides by 3. It's a positive number, no effect on inequality. I get minus 27. Or, multiply both sides by 3, you get x is greater or equal to minus 9. I'm going to put the number line down. By the way, this is the solution to the problem. But I can put the number line down. And the number line has two numbers that go down. One of the numbers is minus 27, and the other number is minus 9. What does it say? X is less than minus 27. That's over here. And the other one says x is greater than minus 9, and that's over here. That's the graph. I got that done. And what's the other thing? The interval notation. Let's write that down. Minus infinity to minus 27. Don't touch. Union. Minus 9 to infinity. Put a box on that. By the way, they did say graph it. If you want to, you can put a box on it as well, but I think it's pretty obvious that's the only graph on the piece of paper there. So what do you do now? You go to the next question, and we're kind of barreling through this. Number 7 is a difference quotient. And yeah, we actually did one before the exam started. and that was on Wednesday. But I'm going to do it now. I'm going to do it in pieces, just like we did in class. F of x plus h. What's that going to be? X plus h squared minus 3 times x plus h plus 1. This is going to be x squared plus 2xh plus h squared minus 3x minus 3h plus 1. Now we're going to do f of x plus h minus f of x. I'm doing it in pieces. And that doesn't look too bad to do, by the way. And really what I'm doing, I'm taking this away. So I got that covered, and this is gone, and this is gone. And what are you left off with? Let's write it down. You're left off with 2xh plus h squared minus 3h. Next up, I'm going to do f of x plus h minus f of x over h, with the understanding that h is not equal to 0. And that's an important fact, by the way. So what do you get? You get 2xh plus h squared minus 3h over h. I divide by h, and it's term-wise division. First term, 2xh divided by h is 2x. The next term, h squared divided by h, is h. And the last term would be minus 3h over h, which is going to be 3. All right, we got this over here, and we move on. All right, move on to the next question. That was number 7, right? I guess we'll go to number 8. And number 8 says a rectangle. It says length L and width W. Well, I'm going to draw a picture of that. It's a multiple choice question, by the way. So I'm going to say this is the length, and this is the width. All right? So it says, the diagonal's 10. All right? Now, certainly, someone says, I wonder what the question is, but they want to express the perimeter P. Well, let me write this down. P is the perimeter. So there's 2 L's plus 2 W's. I got that part done. But they don't want the W in it. They just want it in terms of L. So they want P as a function of L. Well, I'm almost there. It's 2L plus 2W. Now, I got to figure this out, by the way. I'm going to use Pythagorean theorem. So L squared plus W squared equals 10 squared. This is Pythagorean theorem, by the way. And again, we're looking at this over here, that picture. And that would be 100, because the diagonal's 10. So what do you get over here? Well, let's take a look. W squared would equal 100 minus L squared. I want to point out both L and W are non-negative numbers. They're positive, all right? So I got W. I don't have to worry about plus or minus over here. It's just the root of 100 minus L squared. So let's write that down. It's the root of 100 minus L squared. All right, look at the K, and you're going to look around for that. And do I see that? I do. And where do I see that? Right over here. So the correct choice would be B, because it's what I just derived, which is 2L plus twice the root of 100 minus L squared. All right, let's go to number 9. Number 9, I got a picture, and I notice you're hitting with 2 points in the picture. And I tell them what those points are, at least the x-coordinates of it. I'll write this down for you, and then we'll get to the questions. This point over here is the root of 5 over 2, and this point over here is minus the root of 5 over 2. All right? So I'm gonna compute the y-coordinate now, and it looks pretty easy to do, by the way, because I'm looking at the function, and I'm going to plug this number in now. And now whether I use plus or minus 5 is always going to be the same thing, by the way. Just see that right away. And what do you get over there? Well, f of plus or minus the square root of 5 over 2 is relatively simple to do. It's going to give you 25 quarters, and then you're going to get, let's see, minus 25 halves, and then you're going to get plus 4. I'm going to be very careful here. And by that, careful, I'm going to just simply look at it and say, let's see, 25 quarters minus 50 quarters would be minus 25 quarters. That's not so bad. And then 4 in terms of quarters, 16 quarters. So I get minus 9 quarters now. So both of these numbers here, the ordinate is minus 9 quarters. All right? If you're interested, you can also put this point down. It looks pretty obvious to me. It's 0, 4. Let's answer the questions. Is it even, odd, or neither? Well, looking at it, I clearly see it's even. If you want to write this down, what is it really saying? That f of x is identical to f of minus x. And you can verify that if you want, but there's no need to. You're looking at a picture. What's the domain of this thing over here? Well, there's no even roots and there's no division, so the domain is all real numbers. All right, I put a little box in that. Next thing is range. Range means I need to look at the picture, and I'm looking at it. And again, the range is the output, what the y values are. Well, it appears the y is starting at minus 9/4, certainly touching it, and going off to infinity. All right, put a box in that too. All right, let's keep moving along. And the next one is, where is f increasing? Now, what does that mean when you move left or right? It's going uphill. Well, certainly it's going uphill here, and it's going uphill here. Now, someone says, oh, the graph stopped. It doesn't. It goes on forever. All right? So let's write this down. Where's it increasing? Well, I'm looking at it, and it's along the axis because I'm moving left or right. So it looks like from minus the root of 5/2 up to 0, and then it starts up again where? At the root of 5/2, and this is where it's increasing, by the way, off to infinity. Put a little box in that. And, move to the next one. And the next one is going to be, where's it decreasing? And let me just emphasize what that means. And that means we're going down. All right, we're going down. All right, we're going down. Where's it going down? Well, minus infinity, all the way up to minus the root of 5/2. Union, well, it looks like 0 up to root 5/2. Again, there's a reason I'm using open intervals, because when you transfer to Math 121 here, they define it slightly differently, all right? But right now, formally speaking, if you used inclusive intervals over here, except at infinities, you'd be fine too, all right? Let's do the y-intercept. I'm looking at it, clearly see it. What's that going to be? The y-intercept would be when x is 0. I'm going to get what number there? I'm going to get the number 4. That's done. What are the x-intercepts? Well, I'm looking at it, and there's 1, 2, 3, 4. You could probably get it by looking at it, but you could also get it by solving an equation, all right? But I'm going to just simply say the x-intercepts are going to be, again, looking at the picture, minus 2, 0. The next one is minus 1, 0. The next one, again, looking at the picture, 1, 0. And the next one, looking at the picture, is 2, 0. A little box in that. And if you want to do the work on that, you can. The work would be, when does the function equal 0? Well, the function's x4 minus 5x squared plus 4 equals 0. You're going to factor that. That's x squared. Looks like minus 1 x squared minus 4. And that would be x plus 1, x minus 1, x plus 2, x minus 2 equals 0. Well, as we said, the x-intercepts would be, minus 2, minus 1, 1, and 0. And that's all the roots of that. All right, so relative maximum, I'm seeing it. That's right over here. That's the relative maximum, by the way. I'm going to say it's a point. I'll put the point down for you, 0, 4. Put a box in that. The relative minimums, well, these are the relative minimums over here. And let me write that down for you. So it's going to be, well, the first one is minus root 5/2. And then what do you get? Let's make sure, minus 9/4. And the other one was the root of 5/2, and it was still minus 9/4. There's actually 2 of them. All right, we're done. Thank you for paying attention. Hope you did well in the exam. Thank you. Bye-bye.